Hi ladies, today we are going to talk about the volume of pyramids, cones, and spheres. And you can take a look at my beautiful drawings here of what they could look like. The first thing that I would like to do is just talk about the different volume formulas that we can use for pyramids, cones, and spheres. And we will go ahead and start with the pyramid. So I've drawn a diagram here. I can kind of bring you through it a little bit just to demonstrate how we can come up with the volume formula for a pyramid. It turns out that the volume for a pyramid is 1/3 that of the volume of the prism with the same base and height. So what I did first here was that I drew a rectangular prism like so, and then inside I constructed a pyramid. So like let's say it's going to go to the center vertex here. Do you see it coming together? I know this is not the best drawing. So this pyramid has the same base and height as the rectangular prism it is a part of. And it so happens that it will fill up 1/3 of the space of this rectangular prism. And we can use that idea to come up with the volume formula. So to find the volume of a pyramid, we're going to take 1/3 the area of the base times the height. So we are working with the same volume formula we were working with before in terms of different types of prisms. If you have a square base, you're just going to take length times width to find that area. If you have a triangular base for the pyramid, you will have to take half base times height. So a lot of other formulas will come into play. Don't worry, I won't be giving you any trapezoidal pyramids, though those would be pretty fun and funky to work with, I have to admit. So let's take a look at an example of how we can apply this volume formula. Let's look at page 27, the handout you were given, number 1. Okay, with number 1, we are given a triangular pyramid. Remember, you want to look at the base, and the base is in the shape of a triangle. So when I'm finding the volume, I need to find the area of the base. Now remember, the triangle area is half base times height of that triangle, and then times the larger height of the pyramid itself. Okay, so what does this mean? Well, what do we have? If we take a look at the base, we have a right triangle, and it has lengths of 12 inches and 12 inches. So its base and height are each 12 inches. The height of the pyramid itself is 17 inches. Before I just go ahead and calculate this using my calculator, let's simplify this a little bit. Half of 12, you can do that in your head. That is 6. And then you can do 6 times 12 in your head. Remember, 6 times 10, 60. 6 times 2, 12. That would give you 72. So I'm just simplifying it a little bit more before I type it in. And when you type in 1/3, I recommend you do it this way. You type in parentheses 1 divided by 3 parentheses, and then you can hit times 72 and then times 17. So go ahead and calculate that, please. You should get 408. We are still working with cubic units, so my final answer will be 408 inches cubed. Okay. Let's take a look at cones for a moment. With a cone, it's very similar to that of a pyramid in the sense that the volume of a cone is 1/3 the volume of the cylinder with the same base and height. So if I was to draw a cylinder, let me start with that first. And then again, let me just choose another color here. Let me choose a point for my cone. Okay, it's equal to this volume here of the cone is 1/3 that of the volume of the cylinder with which it's a part of. So when we're talking about calculating the volume of a cone, we can say that it's 1/3 the area of the base times the height. So same idea, 1/3 area of base times height. What's different in this case is that we know that we're always working with a circle for the base. With the pyramid, you might have a square, a rectangle, a triangle, some other type of shape, but with a cone we always have a circle. So I can define this volume formula a little bit more. So 1/3, well, what's the area of a circle? That's pi r squared times the height h. So I can just write it like that. Let's go ahead and take a look at number 2 on page 27 and figure that one out together. Just a very basic example of applying the formula and figuring out the volume of the cone. So in this case we have a height of the cone of 3 yards, and we have a diameter of 3 yards as well. We don't want to be working with diameter, so I'm going to cut that in half, and I'm going to say that the radius is 1.5 yards. Okay, so the volume is 1/3 pi r squared times the height. There are lots of numbers involved here. Please write them all out. If you calculate, you just give me a final answer and it's not right, I'm not quite sure what you did. Maybe you left the height out, or maybe you squared the wrong number. But if you write it all out, at least you'll know whether or not you're on the right track. Again, when you type this into your calculator, I suggest doing parentheses, 1 divided by 3 parentheses. That will give you the 1/3. Then you can hit second and then the pi button, 1.5 and then the x squared button, and then times 3. And when you hit enter, you get a long decimal. We can go ahead and round to the nearest tenth, and this will give us a volume of 7.1 cubic yards. So that's how we can calculate the volume of a cone. Let's take a look at a sphere. Okay, so we have a volume of a sphere here. This is cool. A sphere in general, it's a set of points in space that are a given distance r, which could be like a radius, from a center. So you take a center point and let's say you want to go 3 inches out from that center point everywhere, in every direction. That's what formulates the sphere. And if you placed a sphere inside of a cylinder with the same radius, okay, so same radius, the volume of the sphere is 2/3 of the volume of the cylinder. It can't be 1/3 because that's a cone. It wouldn't make sense to have the same volume formula because a sphere is not a cone. So it turns out that it fills up a lot of that space inside of that cylinder. And let's go ahead and show how we can write the volume formula for a sphere. This is kind of cool. So we know that it's 2/3 the area of the base times the height. Okay. Our base is pi r squared because it's a circle. We're given our height, and I know that it's 2/3 this amount. And the other interesting point to make is that the height h is actually equal to 2r, okay, 2 of the radius, because that's the diameter, okay, the diameter here. And if I was to draw that, okay, so if this is my center coming out, you know, that's r, which means this has to be r. Ooh, this keeps popping up. So to get all the way down to the height, we have another r. Okay, so that's where the h equals 2r comes from. And then I can simplify Here's where our algebraic simplification rules come into play. So we can use the associative and commutative properties. And you can do this. Can you simplify this for me? So I have 2/3 times 2 times pi times r squared times r. We can use all of our rules. You should get, we'll keep it 4/3 for now, 4/3 pi r cubed. So that's how you can develop the volume for a sphere. We can keep it 4/3 instead of saying 1 1/3 because you're going to get a repeating decimal either way. 4 1/3 is 4.3 repeating. I'm sorry, 1.3 repeating. So we might as well just keep it as 4/3, and that's typically how you will see it presented. Okay, but if you can't memorize this, just remember that you can derive it, and your height is always going to be given by the diameter or twice the radius. So those are some things just to point out. Let's take a look at page 27, number 3. And what I'd like you to do is to go ahead and apply this volume formula to number 3. Hit pause, hit unpause when you're ready to see the solution. Okay, so in number 3, you should get, when you substitute your values in, 4/3 pi, and then they give you the radius of 7 feet. And we will have to cube that. So when you do that, you will get 1,436.8 feet squared. I'm sorry, cubed. Now, if you're not sure how to type this into your calculator, remember that you can use the caret button, and that's right underneath the word clear, the clear button. So you can type in 7 caret 3, okay, and that's 7 cubed. Please do numbers 7, 8, and 9 on the same page. Hit pause, and when you're ready to see the solutions, hit unpause. Okay, so with number 7, taking a look at that one. Find the volume of a rectangular pyramid with a length of 14 feet, a width of 12 feet, and a height of 9 feet. So we're working with a pyramid, and it has a rectangular base. If you need to draw a picture to help yourself identify what pieces you have and what you're trying to find, please do that. So I have 14 feet. This is not drawn to scale. I have 12 feet, and I have a height, which has to be perpendicular there. Height of 9 feet. Volume is 1/3 that of the area of the base, 12 times 14 because it's a rectangle, times the height of 9. So just make sure that these are the numbers that you typed into your calculator, and this is how you arranged it. You will get a volume of 504 cubic feet. With number 8, we're now being asked to find the radius instead of finding the volume, because we're given a volume of 972 pi cubic centimeters. So this is pretty fun. Instead of multiplying by pi and giving us a decimal, a more exact answer is just to type, and it's fine to leave your number like that. We can calculate it in just a moment. Find the radius of a sphere. Well, we're working with a sphere, so I know I have the formula 4/3 pi r cubed, and we don't know what r is. Well, this one's going to be tricky. Okay, but we can go through it. I'm going to go ahead and show you some neat things with number 8. I won't expect you to do this, to know how to do this on an assessment, but this is still pretty neat. So let's go ahead and divide pi out from each side. Pi divided by pi is just 1. Then I'm left with 972 equals 4/3 r cubed. I'm also going to divide by 4/3, or you can multiply by the reciprocal of 3/4. So go ahead and type that into your calculator, and again you can use parentheses around the 4/3 to get your number. So you'll get 729 equals r cubed. Now you may have taken the square root of each side. That only works with squares. That undoes a square. So in order to calculate what r is, you have to think of what number times itself 3 times gives you 729. You could also take what is called the cube root, but we haven't learned how to do that, so I'm not going to show you yet. So again, no square roots because this is not a square. Can you come up with an integer? And this does work out really nicely, that when you take it and you multiply it by itself 3 times, you get 729. Well, let's go ahead and think of another some numbers we can work with. I actually have to stop